Okay, so new quadrilateral. So this one is a rhombus. Okay, and we know it's a rhombus because obviously you've got four sides, but each of the sides is the same length. Okay, and in this case, what they're asking us to do is prove that the diagonals bisect at right angles. So what they're asking here is that this angle through here, so if we go through the diagonals, through here and through here, what they're saying is that this angle here has to be a right angle. Okay, a right angle, okay? This question is similar to one that you often get with a kite as well. So you'll be able to use the same theory for a question to do with that. Okay, effectively what we need to do here is to show that these two angles here on either side, here where it bisects, are equal. And what you have to remember is this line from P to R is a straight line. So therefore this angle here is 180 degrees. Okay, now if we can cut through that and it's equal on both sides, then both sides will be work value of 90, so 90 plus 90 equal 180, okay? So as long as we can prove that they're equal, that proves that they're 90 degrees, it proves that they're right angles. So that's where we're heading with this. Okay, so when we look at a diagram, what we can see here is actually different types of triangles. So we've got these large triangles like this. So P to R to S to P, that large triangle, and you've got the same on this side. But then you've got these four smaller triangles. So the first thing we're going to do is we're going to try and prove that the triangle PRS is congruent to the triangle PRQ. Okay, so PRS, so this triangle here, and PRQ. So that's the first one we're going to try and prove. Okay, so what we can say here with this, we can say that this side here, PS, okay, so we can say that PS, so side, so PS is equal to this side here, QR. Okay, we can say that the side here, SR, is equal to the side here, PQ. Okay, that's also a side. And the final one, so we've got side, side, side as our congruence test, is PR is common. So now the side, side, side congruence test proves that the bigger triangle PRS and PRQ, they are congruent to one another. Okay, so it's proven that side of things. Call this inner circle here with O, and we're going to prove that POS, so this one in here, okay, we're going to prove that it's congruent with the one on this side here. Okay, so this is what we're going to prove now. We're going to prove that the triangle, so that's the smaller triangle, POS, is congruent to the smaller triangle here, POQ. Okay, all right. What we can look here and we can see that we have this vertically opposite angle here. Okay. Okay, so we have a vertical opposite angle here. So we have the angle POS, and it's equal to the angle here QOR. Oops. Okay. We have the side length here PS, and it's equal to the side length here QR. Okay, and then we can go with one of the alternate angles here. So we can say that this angle here, okay, is going to be the same as this angle here. So we can go with the angle here, angle PSO. PSO is equal to this angle here, which is RQO. Okay, so we have an angle, side, angle. Okay, and now we can say here that triangle POS is congruent to angle POQ, and we can say that the angle, side, angle congruence test proves that. prove now that, so now that we know that this triangle is congruent that one, we can now say that this line here, PO, is equal to this line here, RO. So PO is equal to RO, and therefore SO is equal to QO. So other things, okay, so let's just look at what we know now. We now know that these triangles are also congruent to one another. So we know also that the line PO is equal to the line RO, okay? And we know that SO is equal to the line QO, okay? Prove the two smaller triangles adjacent to each other are congruent. Okay, so we can look at these ones that are adjoining one another. So we have PS and PQ. Okay, so PS equals PQ. Okay, so that's a side, right? And that's obviously given by the dashes, okay? We can see that the line PO is common. So that's a side, okay? And we can see that the line SO equals QO, and we showed that up here, okay, before, because it was proven by the previous proof of these two triangles being equal, okay? So again, that's side, side, side. So now we can write a congruent statement that says that the triangle POS is congruent to the triangle POQ. And that's with side, side, side as the congruence test. We can now see that the angles POS, so POS, so it's at that angle in here. Okay, we can say that's angle POS is equal to the angle POQ, that angle on that side. Okay, and that's where we were trying to get to in the end. Okay, we were trying to get to the ability to be able to make the statement that these two angles on that straight line were equal to one another. From that, we can now go, therefore, okay, the angle POS equals 90 degrees, and the angle POQ equals 90 degrees, and they are both right angles. And that proves part A of our question. So now we can see that cuts through at 90 degrees, and so if that one cuts through at 90 degrees, the opposite side must cut through at 90 degrees. So that means that that's 90, that's 90, that's 90, that's 90. So that means that both diagonals bisect at 90 degrees or at right angles. Okay, so that's proven by that. Okay, so now we're going to look at the idea of lines bisecting. So bisecting means that for an angle, so let's say it's like this, if a line cuts through it, okay, if it bisects it, then what that means is that the angle on one side is equal to the angle on the other side. It cuts them into two equal parts, okay? So that's what we're going to try and prove here. In terms of these lines that cut through, do they cut these angles equally? And really to prove that, what we need to prove is that the remaining angles are all equal to one another. And if they're equal to one another, then they've been cut equally, and that means the line cutting through is bisecting it. Okay, so we can start this by looking at our triangles that are on here and going, right, so here we have a triangle PSR, so this large triangle here, and we have another triangle here, PQR, another one here. And these triangles are isosceles triangles, so they've got two sides that are the same length, and each side has an angle that is the same. So it's an isosceles triangle, okay? And these sides are the same length. So that's this triangle here, PSR. And so from that we can say that this angle here, SPR, so this angle here, SPR, is equal to the angle down here, SRP. So we can make this statement here. So that angle is the same, okay? We can do the same with the other side on this triangle on this side, okay? So again, we have this isosceles triangle, and we have this angle here. Okay, let's do it with slightly different colours like that, so you can tell the difference. Okay, and we can see here that the angle here, QRP, so this angle down here, is equal to the angle QPR, which is up here. Okay, now these angles are in fact the same. Okay, and we know that from our previous work on the congruence of the triangles, that the two triangles are the same, so therefore these angles are all equal. So we can actually say in this statement that the angle SPR equals the angle SRP equals the angle QRP equals the angle QPR. So those four are all identical. Okay. If that's true and all of those are the same as one another, okay, you can then state that in order for that line to cut through, it bisects it because each of these is true. So that's equal to that, that's equal to that, this is equal to this one, this is obviously equal to this one here. So they're all equal to one another. So all angles in this particular case are equal. Therefore, the line bisects them because the angles are equal.